Hi friends, welcome to all. In this video, we are going to solve this packet tracer activity, configure and modify standard IPv4 ACLs. Before coming to this activity, friends, if you like to get any CCNA version 7 online classes or any technical support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get this type of technical videos in future, consider subscribing and don't forget to enable that bell icon so that you will get notification message whenever we upload a new video. Now we are back to this activity. Here we can see our addressing table. Coming to the objectives, part 1, verify connectivity. In part 2, configure and verify standard numbered and named ACLs. Then in part 3, modify a standard ACL. We will go through the scenario. Network security and traffic flow control are important issues when designing and managing IP networks. The ability to configure proper rules to filter packets based on established security policies is a valuable skill. In this lab, we will set up filtering rules for two business locations that are represented by R1 and R3. Management has established some access policies between the LANs located at R1 and R3, which you must implement. The edge router sitting between R1 and R3 has been provided by the ISP, will not have any ACLs placed on it. You would not be allowed any administrative access to the edge router because you can only control and manage your own equipment. We will go to the instructions. In part 1, verify connectivity. In part 1, we will verify connectivity between devices. They given a note. It is very important to test whether connectivity is working before you configure and apply access list. You want to be sure that your network is properly functioning before you start to filter traffic. Yes, that is very important. We will verify the connectivity. From PC-A, ping PC-C and PC-D. Where you are ping successful, we will do that. We will get the IP address of PC-C. Then we will go to this PC-A command prompt, desktop, then command prompt. Here I will give that ping command, then IP address, and we are waiting for the replies. You may get 1 or 2 requests timed out. Yeah, here we can see we get the replies. Now we will ping to PC-D. Ping to PC-D. Okay, here we get the replies. Here pings succeeded from PC-A to PC-C and PC-D. Now from R1, ping PC-C and PC-D, where your ping successful. Okay, we will get the IP address of PC-C. We'll go to R1 CLI and here enable, and we will give ping command, then address. So we can see success rate is 100%. We will get the IP address of PC-D. Coming to R1, ping to PC-D. So success rate is 100%. This is succeeded. Now from PC-C, ping PC-A and PC-B, where you are ping successful. So we will go to PC-C. We will get the IP address of PC-A. Coming to PC-C, desktop, command prompt, ping, and here we get the replies. Now we will ping to PC-B. So we may get 1 request timed out. Here we get the replies. Then from R3, ping PC-A and PC-B, where your pings are successful, we will get the IP address of PC-A. Coming to R3 CLI, enable, then we will ping to PC-A. Here we can see success rate is 100%. Also we'll get the IP address of PC-B. We have to go to R3. Okay, it's working. Then can all of the PCs ping the server at 209.165.200.254? We will test that. I will copy this IP address. Coming to PC-A. Okay, we are waiting for the replies. So PC-A can communicate. Then we will go to PC-B. We are pinging from this all these PCs to this server. We'll try from PC-B. Ping to our server. Okay, we get the replies. We'll go to PC-C. Ping to the server. We get the replies. We'll go to PC-D. Ping to the server. Perfect. Coming to part 2. Configure and verify standard numbered and named ACLs. Step 1. Configure a numbered standard ACL. Standard ACLs filter traffic based on the source IP address only. A typical best practice for standard ACLs is to configure and apply the ACLs as close to the destination as possible. For the first access list in this activity, create a standard numbered ACL that allows traffic from all hosts on the 192.168.10.0/24 network and all hosts on the 192.168.20.0/24 networks to access all hosts on the 192.168.30.0/24 network. The security policy also states that an explicit deny any access control entry, also referred to as an ACL statement, should be present at the end of all ACLs. Okay, here we will allow only these hosts from these networks 10.0/24 and 20.0/24 to access this network, that is 30.0. So we will identify these networks in this topology. We will go to this router R1. Enable, here I will give a show IP interface brief command. And here we can see 192.168.10.1 and 20.1. Even we can see this in routing table, show IP route connected. Here we can see those networks at 10.0 and 20.0, which is directly connected to G0/0/0 and G0/0/1. So coming to our topology, here we can see those networks. Here is a G0/0/0. Then here we can see G0/0/1. Next we will identify this 192.168.30.0/24 network. Coming to R3. Enable show IP route connected. And here we can see 192.168.30.0/24 is directly connected to G000. Coming to our topology, here we can see that interface G0/0/0. Now our ACL policy is clear. That means this network and this network only allowed to access this network, and all other networks not allowed to access this network. What wildcard mask would you use to allow all hosts on the 192.168.10.0/24 network to access the 192.168.30.0/24 network. So here the prefix they given as a /24, that means the wildcard mask will be 0.0.0.255. Following Cisco's recommended best practices, on which router would you place this ACL? So here we read that a typical best practice for standard access control list is to configure and apply the ACL as close to the destination as possible. So here our destination is 192.168.30.0, so we can implement this ACL in this router R3. On which interface would you place this ACL? In what direction would you apply it? So here we can see our destination network is here, and it is connected to this interface G0/0/0 in this router R3, and we have to apply this ACL in out direction. Here, configure the ACL on R3. Use 1 for the access list number. Here they given the command access list 1. They set this remark first: allow R1 LANs access. Then access list 1 permit. Here they given the source address 192.168.10.0 and 192.168.20.0. And finally they given access list 1 deny any. That means only these two networks are allowed to access this 30.0 network. Okay, we will give these commands here in this router R3. We will go to global configuration mode, conf-t, and here we will give access list 1, and we have to give the remark, right? Allow R1 LANs access. Then we will create access list 1, and we will permit 192.168.10.0. then we have to specify the wildcard mask 0.0.0.255. also we will give access list 1 permit 192.168.20.0 wildcard mask 0.0.0.255, and we have to give access list 1 deny any. Then apply the ACL to the appropriate interface in the proper direction. Yeah, already we discussed we have to apply this ACL to this interface G0/0/0 connecting to this network, that is IP access group 1 in out direction. We will do that. We have to go to that interface, that is a G0/0/0, and here we will give IP access group, that is 1 direction out. Now we will verify a numbered ACL. The use of various show commands can help you to verify both the syntax and placement of your ACLs in your router. To see access list 1 in its entirety with all ACs, which command would you use? Obviously we can use a show access list command. What command would you use to see where the access list was applied and in what direction? We can use a show IP interface, then the interface name, that is a G0/0/0, where we applied our access control list, or even we can see this using show IP interface command. On R3 issue the show access list 1 command. Okay, we will give that. Give end show access list 1, and here we can see standard IP access list 1. Here we can see the command we given: permit this network and its wildcard mask, then permit 192.168.20.0, then deny any. Then on R3 issue the show IP interface G0/0/0 command. Okay, so that we can see the direction. We will give show IP interface, that is a G0/0/0, and here we can see the direction. Here is the command. Here we can see outgoing access list is 1. Perfect. Next is test the ACL to see if it allows the traffic from the 192.168.10.0/24 network to access the 192.168.30.0/24 network. For that, from the pc-a command prompt, ping the pc-c IP address. Where the ping successful, we will test that. We will get the IP address of pc-c. Then we will go to pc-a command prompt. Then we will ping to pc-c. Perfect, we get the replies. Then test the ACL to see if it allows traffic from the 192.168.20.0/24 network access to the 192.168.30.0/24 network. From the pc-b command prompt, ping the pc-c IP address. Where the ping successful, it should succeed. We will test it. We will ping to pc-c. And here we get the replies. That means it is pinging. Should pings from pc-d to pc-c be successful? Ping from pc-d to pc-c to verify your answer. So we'll ping from pc-d and ping to pc-c, and it will not succeed. Here we can see destination host unreachable, because only these two networks are allowed to communicate to this network. Next is from the R1 prompt, ping pc-c IP address again. Okay, we will ping from R1 and it will not succeed. Okay, we will see that. Ping to pc-c, and here we can see success rate is 0%. Yes, why it's failed? When we ping from this R1 to this network, R1 uses the IP address of this interface serial 0/1/0, which is near to this destination. And this network is not allowed to access this network. Only these two networks are allowed to access this network. Now, issue the show access list to 1 command again. Note that the command output displays information for the number of times each ACE was matched by traffic that reached interface gigabit Ethernet 0/0/0. We will go to R3 and we will give that show command. Show access list 1, and here we can see the matches. And here we can see in deny any, we got 9 matches. Now we will go to step 2. Configure a named standard ACL. Create a named standard ACL that conforms to the following policy. Allow traffic from all hosts on the 192.168.40.0/24 network access to all hosts on the 192.168.10.0/24 network. Also, only allow host to pc-c access to the 192.168.10.0/24 network. The name of this access list should be called branch-office-policy. Here, this policy says all the hosts in this network and only this pc-c from this network is allowed to access this network, that is 192.168.10.0/24 network. Following Cisco's recommended best practices, on which router would you place this ACL? Obviously, we have to implement this ACL near to the destination, that is on R1. And on which interface would you place this ACL? In what direction would you apply it? Obviously, we have to apply to this interface G0/0/0 in out direction. Now we will create the standard named ACL branch-office-policy on R1. Just I will copy this name, and here we can see the command IP access list standard. Then we have to specify the name of the ACL. Then we have to permit only this host, so we have to specify host. Then the IP address of that host, the IP address of this PC-C. Then we have to permit all the hosts in this network, that is 192.168.40.0 network. And here they did not give that deny any command here. Okay, anyways, we will see that. We will go to R1 and we will give these commands conft, and here we will give IP access list, and here we can see it start with IP access list standard. Then we will give its a name. I already copied it. Okay, then press enter. Then we will permit host 192.168.30.3. This is the IP address of our PC-C. Then press enter. Also we will permit the network, that is 192.168.40.0. then wildcard mask 0.0.0.255. Look at the first ACE in the access list. What is another way to write this? So this is the first command we given, permit host, then its address. We'll go to R1 and we will check that. Permit, we have host, then we given 192.168.30.3. then we'll put space and a question mark. Here only shows enter, but even we can give this 0.0.0.0. Let me try with this. Anyways, here we are not going to give because it will be added in the access list. So we can use this command permit 192.168.30.3. then we can give space 0.0.0.0.0. Now we have to apply the ACL to the appropriate interface in the proper direction. Yes, we have to apply to this interface G0/0/0 in out direction. Okay, we will go to R1 and we will do that. Exit, because we have to go to interface G0/0/0, and here we have to give IP access group. Then we have to specify the name. I think already we copied it. Branch-office-policy, and we have to give the direction, it's out. Next we will verify a named ACL. On R1, issue the show access list command. So we'll go to R1 and here we will give that command, give end, then give show access list. And here we can see standard IP access list branch-office-policy. This is what we created, and here we can see line 10 and 20, and here we cannot see that line number 30, that is deny any. There is a question, is there any difference between this ACL on R1 and the ACL on R3? If so, what is it? Yeah, we have seen, let me show. In R3 we have 3 lines, show access list. Here we can see the third line, 30 deny any, and we did not give this line here. And here we can see only 10 and 20, 2 lines. Okay, now on R1, issue show IP interface G0/0/0 command to verify that the ACL is configured on the interface. Okay, coming to R1, show IP interface G0/0/0, and here we can see outgoing access list is branch dash office dash policy. Now we are going to test the ACL. From the command prompt on PC-C, ping the IP address of PC-A. Were the ping successful? Okay, we are going to ping from PC-C to this PC-A. We will get the IP address of PC-A. Then we will go to PC-C, command prompt, ping to PC-A. And here we get the replies. Because this host PC-C is allowed to access PC-A. Now, test the ACL to ensure that only the PC-C host is allowed access to the 192.168.10.0/24 network. You must do an extended ping and use the G0/0/0 address on R3 as your source. Yes, we can do that. Ping PC-A's IP address. So we have to give ping and then press enter from R3. So we'll go to R3 and here we will give a ping, then press enter. Here we can see protocol IP. We will give 192.168.10.3. This is the IP address of our PC-A. Okay, but here we can see we get the error message. The reason is we given here IP address for this protocol. So here we have to give either IP or simply we can press enter so that it will accept this default protocol, that is IP. That's fine. So we will give ping again, then press enter. So here again we will press enter so that it will take the protocol IP. Now we can see target IP address, the IP address of this PC-A. It's 192.168.10.3. That's fine. So repeat count. So by default it's 5. Okay, just we will leave as it is. Press enter. And datagram size 100. That's fine. Just press enter. Then timeout in seconds. By default it's 2. That's fine. Then extended commands. So we will give yes. We need extended commands. Then source address or interface. So here we are going to give the IP address 192.168.30.1. That means the IP address of this interface G0/0/0. We will give that 192.168.30.1. Then press enter. And type of service 0. Okay, press enter here again. No. Press enter again. Press enter again. Okay, enter. Enter. And we can see success rate is 0% because we ping from this interface, that is 192.168.30.1, but this address is not allowed to access this network. Only this PC-C is allowed to access this network. Were the pings successful? No, it is not succeeded. Next, test the ACL to see if it allows the traffic from the 192.168.40.0/24 network access to the 192.168.10.0/24 network. From the PC-D command prompt, ping the PC-A IP address. Where the pings are successful, it should succeed because we allowed this network to access this network. So we will get the IP address of PC-A. Then we will go to PC-D command prompt and ping to PC-A. Perfect. We get the replies. Next we will go to part 3, modify a standard access control list. It is common in business for security policies to change. For this reason, ACLs may need to be modified. In part 3, we will change one of the ACLs you configured previously to match a new management policy that is being put in place. Now, Attempt to ping the server at 209.165.200.254 from PC-A. Notice that the ping is not successful. The ACL on R1 is blocking internet traffic from returning to PC-A. This is because the source address in the packets that are returned is not in the range of permitted addresses. Okay, we will attempt to ping to this server using this address from this PC-A. Ping to our server, and we are waiting for the replies. Request timed out. No, it's not working. Packets sent 4 but received 0. Lost for 100% loss. Why this communication is failed? Because here only this network and this PC-C is allowed to communicate with the PC-A. But here PC-A can communicate to the server. Yes, he can communicate. But when the acknowledgement come back, this server cannot communicate to PC-A. I think I will show in simulation mode so that it will be more clear. We will go to simulation. Let me maximize this. And here I will click on show all none. Then edit filters. Here we will choose only ICMP. Now we will see why it's not pinging. So I will go to PC-A command prompt. Again we will ping to our server. And here we can see our ICMP packet. Yes. So we'll click on capture bar forward. It goes to S1 and it goes to R1, then goes to edge, then to the internet, then it goes to server. We can see that packet reached in this server. Now this server is going to send acknowledgement back to this PC-A. So it comes to the internet, then it goes to edge, and then we can see it will go to R1, but we can see this R1 will drop this packet. Why this R1 is drop this packet? Because this network is not allowed to access this network. That's why he dropped this packet here. Now management has decided that traffic that is returning from the 209.165.200.224/24 network, okay, from this network should be allowed full access to the 192.168.10.0/24 network. Management also wants ACLs on all routers to follow consistent rules. A deny any ACE should be placed at the end of all ACLs. You must modify the branch-office-policy ACL. Yes, actually we did not set this deny any command, even though there will be an implicit deny, but as per the Cisco rules, we have to set this deny any command. You will add 2 additional lines to this ACL. There are 2 ways you could do this. Okay, that's great. Here we can see option 1. Issue a no IP access list standard branch-office-policy command in global configuration mode. This would remove the ACL from the router. Depending upon the router iOS, one of the following scenarios would occur. All filtering of packets would be cancelled, and all packets would be allowed through the router, or because you did not remove the IP access group command from the G0/1 interface, filtering is still in place. Regardless, when the ACL is gone, you could retype the whole ACL or cut and paste it in from a text editor. Here we can see option 2, and this is the best. You can modify ACLs in place by adding or deleting specific lines within the ACL itself. This can come in handy, especially with ACLs that are long. The retyping of the whole ACL or cutting and pasting can easily lead to errors. So we can go with this second option. Modifying a specific lines within the ACL is easily accomplished. For this activity, use option 2. That's fine. Step 1. Modify a named standard ACL. From R1, issue the show access list command. So here in R1, we will give that command. Enable show access list. And here we can see line number 10 and line number 20. Now we are going to add two additional lines at the end of the ACL. From global configuration mode, modify the ACL branch-office-policy. We have to give this command, then we have to add these lines 30, then permit 209.165.200.224, then wildcard mask 0.0.0.31. Also we will specify deny any with the line number 40. Just I will copy this ACL name, coming to R1, and here we can give that conf t. In global configuration mode we have to do that. IP access list standard, and here is the name. Okay, and here we are going to add those lines, that is 30, and here we are going to permit 209.165.200.224. then we have to give a wildcard mask 0.0.0.31. also we will add line number 40, and we have to give a deny any end. Now we will verify the access control list. On R1, issue the show access list command, show access list, and we can see these lines 30 and 40 will be added. Show access list, and here those lines. Do you have to apply the branch-office-policy to the G0/1 interface on R1? Not G0/1, it's a G0/0/0. And no need to do that again, because it's already be given, and it will be there in this router R1. We can verify that. Show IP interface G0/0/0. And here we can see that outgoing access list is branch-office-policy, or even we can verify using show running config G0/0/0. Here we can see that IP access group, then ACL name, and direction out. Hence no need to give that command again. Test the ACL to see if it allows traffic from the 209.165.224/27 network access to return to the 192.168.10.0/24 network. From PC-A, ping the server at this address. We'll go to PC-A and we will ping again. Here is the address. You can press up arrow from the keyboard. Yes, and we get the replies. Were the pings successful? Yes, it succeeded. Okay, that's all in this activity, that is configure and modify standard IPv4 ACLs. Here we can see our completion status, it's 100%. Now dear friends, if you have any doubt, any suggestions regarding this packet tracer activity, please comment below, or you can contact our team using our website. Link you will get from the description below. And if you like our video, give a thumb and share with all your friends. Stay tuned, and we will meet again with the next video. Thank you.